but actually a little bit harder. So I want to get the reactive power in the inductor and the capacitor from the circuit below. So So the first thing I need to do is to change everything to phasors. And so my omega is 1,000, and I get that from these. And so my voltage is 200 angle 0 because there's no additional phase. And I have 50 ohms right there. And my capacitor is minus J over omega C. So this is the impedance for the capacitor, or minus J over 1,000 times 20 times 10 to the negative 6. And if I did that right, that is minus J 50. And then the inductor is J omega L, or J times 1,000 times 30 milli is 0.03. And so that would be J30. And then I have my current source is 4 angle 0. And I forgot when I drew this. Well, I guess I'll work it the way it is and not the... I have a different problem here, so now everything is different. All right, so I call that V right there, and I write a node equation. Then I could say V minus 200 angle 0 over 50 plus V over minus J50 minus 4 angle 0 equals 0. So stop me if y'all have a question on something. So the question that I would be expecting someone to ask, well, what about the inductor? No? Okay. If we're all good with that. Then, so I only have one V, so that's nice. So So this is 1 over 50 times V minus 200 plus 1 over minus J50 V equals 4. .02. point J.02. .02V minus, what is that, 4 plus J.02V equals 4, or V.02 plus J.02 equals 8, or V equals 8 over .02 plus J.02. .200 minus J200. Okay, so now let's see, how do we use that information to find the reactive power in the inductor and the capacitor? So the capacitor will be easier. So let's get the current. How would we get, well, let's take a look at our various different options here. So reactive power could be V squared RMS times X over the absolute value of Z squared. I don't like that. I'm just going to do it the way that I would ordinarily do it. So I'm going to find, so for the capacitor, I'll find the current. So the current, if I make this ground, then I equals V over minus J50, and V we just found was 200 plus J200 over minus J50. So minus 4 plus J4. So I conjugate is minus 4 minus J4. And so the complex power is 1/2 V I conjugate, or 1/2 200 plus J200 times minus J50. Wait, no, minus 4 minus J4. That was supposed to be 200 minus, I had a plus here and this was supposed to be a minus. Do y'all think it's going to change the sign of the real part or the imaginary part? Real. Yeah. So 4 plus J4. 4 plus J4. So conjugate is plus 4 minus J4. Minus J800. So in this case, it's very easy to see what the reactive power is, because the reactive power is the imaginary part, and there only is an imaginary part. So the reactive power for the capacitor is just minus 800. And is that VA or VAR? I think the reactive power is VAR. So minus 800 VAR. Let me double check on that. Stay for at least one more. Oh, you have to leave at 6:30. Yeah, I understand. I get it. Yeah, it's VAR. So the reactive power is VAR because the complex power is VA. Yeah, I knew that. I'm just so the reactive power is VAR. Okay, so and then if I wanted to find the reactive power for the inductor, I couldn't use the voltage because I don't know the voltage across the inductor. So instead, I would have to use something like
solutions to these to work them out, or are you working them out?
you'll have to watch the video, so
Okay.
I'll post the video and you can check it that way. Or you can also always send it to me. If you work it out and send it to me, I'll check it for you.
Sounds good, thank you.
Yep. So we could get the, for the inductor, we could get the, the magnitude of the current squared times 1/2 times the reactance, the X, and get the reactive power that way. But I'm not going to do that on this one unless y'all really want me to, and then because I wanted to do a different problem instead, one where I have the answers so I know that I'm doing it right. Okay, any questions on that one?
What was your voltage that you got? It was positive or negative, J?
It was
Man,
a negative J.
that's 200, correct?
Yes, and so this should have been a 200 here, a negative 200 there.
And then that changed the I, and that's why there's the phosphorus on the floor.
No, yeah, it changed the 4, not the,
Yeah.
yeah. Um, actually, I will go ahead and do the inductor. So, because it's not that hard. So it's I squared X is the reactive power for the inductor. And we know what I is. I is just 4. And it's real. And so it doesn't matter that, I don't have to worry about its conjugate or anything like that. It's a real number. So it's 16 times, for the inductor, it is J30 is X. Oh yeah, this was real easy. So it's just J480 VAR is the reactive power for the inductor.